Okay, everybody, we're going to talk today about zeros of roots and of quadratic functions. Okay, so there's three objectives: being able to factor quadratics, being able to use the factored form of quadratic to find zeros and roots, and to be able to solve quadratic equation using square roots. Okay, so there are three distinct skills. They're all very related. The first one is probably the hardest of them all. And so we'll start right into that. Let's go for it. Okay, so first of all, what is factored form? Well, here's standard form on the left, and you see factored form on the right. These are the same polynomial. They're the same quadratic, but they're in different forms. Okay, we talked a little bit about factored form. We certainly talked about standard form at this point. So this is the factored form again. How do we know they're the same? We FOIL. Okay. Again, firsts, x times x is x squared. Outsides, x times negative 1 is negative x. Negative 2 times x is negative 2x, and negative 2 times negative 1 is positive 2. Combine like terms, and I get the quadratic. So that's how I know that standard form and factored form of an equation are the same. Okay. So how do we go backwards? How do we start at standard form and go to factored form? Well, it's actually not terribly complicated. This is the way I always do it. The first thing I look at is this is a method that works as long as the number that's multiplied by x squared is 1. So there's no number here, just a 1. And I have a number for b and a number for c. The first step is to write out the following. Just write out open parentheses x, give yourself some space, close parentheses, open parentheses x, give yourself some space, close parentheses. That's the first thing to do. Then we want to find two numbers that add to b and multiply to c if they exist. They don't have to. Okay, so I want to find a number here. I'll highlight that spot. A number here and a number here, so that when I add those together, I get b, and when I multiply them together, I get c. All right. Okay. Then we FOIL the solution and check to see that it works. So here's my example: x squared minus 9x plus 20. First thing I do is I write out x and leave some space, and another x and leave some space. Okay. Then I go ahead and fill that in. Now I'm not going to fill them in. I'm going to show you the next slide, the next part here. But I would probably fill these in. So what two numbers could multiply to 20 and add to negative 9? Well, there's only so many numbers that can multiply to 20. What are our options? We've got numbers like I've got 1 and 20. I've got negative 1 and 20. I've got 4 and 5, and I've got negative 4 and negative 5. So all I have to do is look at my factors. These are the only four sets of numbers that can do that. Which two of these add to negative 9? These two do. Okay. Indeed, if I put those in, let's see if it works. I FOILed that out. Hopefully it'll work. X times x is x squared. Negative 4, first, outsides, x times negative 5 is negative 5x. Negative 4 times x is negative 4x. And negative 4 times negative 5 is 20. So I get, indeed, x squared minus 9x plus 20. Yeah. Okay. Well, it's so bad. So here's some common patterns to look at. You can always look out for things like difference of squares. Notice when you don't have a middle term here, there's no x term. One thing to look out for is this is already something squared. 16 is 4 squared. Well, if I notice that those two are both squares and there's a subtraction between them, must be a difference, then it's automatically going to factor as x minus 4, so the square root of this, minus the square root of this, times the square root of this plus the square root of this. It always works, and it's a very nice factorization. I can FOIL it out to see that indeed it does work. Firsts, outsides, insides. Last thing you notice that negative 4x plus 4x, these two go away, just like I thought they should. Okay, here's another one. Try this one for a second, pause the video, and then come back to it when you're done. Okay. All right, so you've finished it, unpause it. Your answer should be negative x minus 5 times x plus 5. Okay, your next common pattern is the perfect square trinomial. Now, I frankly never remember what it's called, but this is how I think about the perfect square trinomial. Okay, it's a situation where I have the square root of this doubled in the middle. Square root of 9 is 3, times 2 is 6. Whenever you have that kind of pattern, really what it is x plus 3, which is the square root of 9, the whole thing squared. So this is like x plus 3 times x plus 3. That's just a fancy way of writing it. Here's another one. Okay, x minus 4x plus 4. The square root of 4 is 2. Double that, and I get, in this case, I get negative 2. So this one can be written as x minus 2 all squared. Now here's how you think about this one. Here's the way to think about this one. It's the first one squared twice their product, the last one squared. So if I want to FOIL out something, x plus something squared, I take the first one squared, which is x squared, 2 times ax, a and x here, plus the last one squared, which is a squared. Very good. This is a less common pattern. This pattern comes up, but you can actually get the answer to this quite easily using the first method that we looked at. This pattern, the difference of squares pattern, is a little bit, it doesn't pop out at you the way the other one will. Okay, very nice. Okay, now here's where it gets a little tricky. What about when you have a number in front of x squared that's not the number 1? So here's an example. 5x squared minus 17x plus 6. Here's how we do it. The first terms must multiply to 5x squared, and the last must multiply to 6. Okay, so instead of being able to put up my open parentheses with an x and an x, as I did before, it's going to look a little different. Here are our options. The only two things that can multiply to 5 are 5 and 1, because 5 is prime. So we have to start with 5x in one parentheses and x in the other. Okay? Because we know the only way I'm going to get 5x squared is by taking 5x and x. And I've got to have an x in both these, so this has to be where they are. 5x times x is the only way I'm going to generate the 5x squared term. Now let's leave the middle term for a minute. We'll come back to it in a bit. And let's figure out what could possibly multiply to the last term. Well, it's a little bit more. It's not prime, so it's going to be a few more options. Okay? Here they all are. Oh my gosh. So it could be 1 and 6. Let me write this out, right? It could be 1 and 6. There's that one, right? It could be negative 1 and negative 6. It could be negative. Okay. Could be 6 and 1. Okay. It could be negative 6 and negative 1. Notice that in order to multiply to 6, they have to be the same sign. They either must both be positive or both be negative. Okay. It could be 2 and 3, or negative 2 and negative 3, or 3 and 2, or negative 3 and negative 2. You get the idea. There's a lot of options. Okay. All right. Let's go back and look at our original one. So our options, we know we have a 5x, we know we have an x, we have something, the combination here is one of these 8 things. That's a lot, okay? Let's narrow it down a little bit. If the middle two things are going to have to, in some way, sort of add to negative 17, except we have that, it's not going to quite add to negative 17 because we'll have that 5 in there to mess things up. If that's going to happen, the only way we're ever going to get two things that add to a negative is if we start with negatives. That means that somewhere in here, the only possibility are going to be the ones that are negative. Okay, these ones are out. I'm never going to be able to multiply to FOIL this out and get negative 17x in the middle with two positive numbers here and here. Okay, so that much we know. We know we have a 5x, we know we have an x, and we know that the other two numbers have to be one of these 4 options. And here's how you do it. You just do it. You just try it. Okay? All right. Well, we know we're going to have 5x squared. Okay, that's true. We set it up so we'll have that. We know we're going to have 6 at the end. What are the two numbers in the middle going to be? We're going to have a negative 5x, because that's the outside. And we know we're going to have a negative 6x. Aha! Is that negative 17? Nope. Okay, that's negative 11. Doesn't work. Let's try the next one. Again, we've set it up so we have 5x squared here and 6 here. Let's try the middle. Okay, the outside, negative 30. x minus x. That's negative. Nope, that's not going to work. Negative 31. Okay. Let's see here. We're going to have, this is looking a little more promising, negative 10x minus, that was close, negative 13x. I hope this is it, because otherwise we're out of luck. Minus 15x. Yes! Yes, it works. Because negative 15x minus 2x is negative 17x. So the factorization of this polynomial, of this quadratic, is right here. Now that's a lot of work for one factorization, I completely admit. Here's the tip. There are plenty of shortcuts and tricks, and I know that I think Ms. Kelly has taught some of them in her class. At the end of the day, it really does come down to trial and error. Okay. Sometimes it'll be, you try 4 factorizations. Sometimes you try more. Sometimes you try just a couple. Okay. Whenever you have these factorizations where this number out here is not a 1, when it's something else, you're just going to have to do a lot of work. Okay. There are some shortcuts, but at the end of the day, it really is a lot of trial and error. And the only thing I would say is take your time, especially on the homework, take your time, and don't get too uptight about it. It's going to be all right. Okay. So, now's where it gets fun. We're going to use the factored form of a quadratic to find roots and zeros. Okay. So first of all, before we talk about that, I want to look at a picture here of a quadratic. I'm going to look at the picture, negative x squared plus 2. Okay. This is a downwards facing parabola that's been shifted up. And what I want to point out here is that, maybe we'll do it plus 4. Okay. What I want to point out about this is notice where it hits the axis. Here and here at x equals negative 2 and x equals positive 2. That's no coincidence. The factored form of this polynomial is going to be x minus 2 and x plus 2. Okay, all made negative. Okay, with a negative in front of all that. So there's a relationship between the factored form of a polynomial and where the parabola hits the x-axis. Okay, so with that in mind, let's move on and talk about roots and zeros. So the zero product property says this, that if you have two numbers that are multiplied together and you get 0, either the first number had to have been 0, the second number had to have been 0, or they both had to have been 0. That's an important point. So what I want to do now is solve for x. And this is the polynomial I had at the second slide, I believe it was. I want to solve for x. I want to find out when does this equal 0. Good question, right? Okay, so I factor it in the way we did in the first slide. I get x minus 4 times x plus 5 equals 0. Now, using the zero product property, I know that either this must be 0 or this must be 0 or both. Okay? So either x minus 4 equals 0 or x minus 5 equals 0, which means that x equals 4 or x equals 5. Now, we should always check our work and plug those in and see if they actually work out. If I plug in x equals 4, I should get 0. If I plug in x equals 5, I should get 0. Okay, so let's see. 4 squared minus 9 times 4 plus 20. 16 is 36 plus 20. Does that equal to 0? It does. This is negative 20 plus 20 equals 0. So 4 definitely works. How about 5? $25 minus 45 plus 20 indeed does equal 0. These are the two places where this parabola hits the x-axis. Okay. How about this one? This is the one that we just did a moment ago. Okay. This factorization, that nasty factorization we did. But now we can use it. Okay. So we can try this one out here, and if we take a look at the factored form that we already did, and set that equal to 0, using the zero product property, we should be able to solve for the values of x that will make this 0. You can go ahead and give that a shot. When you're done, here are the answers. Okay. Finally, this is a square root review real quick. We want to talk about using square roots to solve equations. Now, I have to quickly do a small square root review where we look at square roots. So remember this, that as long as, and this is important, a is bigger than 0 and b is bigger than 0, they must both be positive numbers for these to work. If I have the square root of a number times the square root of a number, it's equal to the square root of the product. 18 I can write as, the square root of 18 I can write as the square root of 9 times the square root of 2. And that's convenient because the square root of 9 is 3. I can do the same thing with division. Okay? The square root of the entire fraction is the same as the square root of the numerator divided by the square root of the denominator. There are no such rules for addition or subtraction. So make sure that you're not telling me something like this. Okay? Not true. Okay. Quick review that in mathematics we don't like square roots in the denominator. So we rationalize the denominator. All it means is we get square roots out of the denominator. And most of the time that means we multiply the numerator of the denominator by that problem square root. And what that does is makes the denominator the same as it was before without the square root though, and puts a copy of the square root in the numerator. These two fractions are the same, but we prefer in mathematics this one. Okay, it's a preference. In the same way we prefer reduced fractions, we prefer 1/2 to 2/4. We also prefer 5 root 2 over 2 to 5 over root 2. Okay, so let's use our knowledge of square roots to solve. Let's take a look at this particular quadratic. I'm going to try to solve this quadratic equation, but I'm not going to do it by factoring. Instead, I'm going to do it using square roots. Okay, so the first thing is to solve for x squared, and then take a square root. There's really only one step to this whole direction. Solve for x squared, then take a square root. Okay, I subtract 5 from both sides to get 3x squared equals 36. Divide both sides by 3. I get x squared equals 12. I take a square root of both sides. Remember, whenever I take a square root, we have the plus or minus. It's really important that we have this because now this means we have two solutions. Positive square root of 12 and negative square root of 12. Okay? And by that rule of square roots, I can separate this into the square root of 3 times the square root of 4. But the square root of 4 is 2, so this becomes the square root of 2 root 3. So there's really two solutions here. It's 2 root 3 or negative 2 root 3. Okay, so one comment about this. This method only works if there is no x term. Okay, this will not work in a polynomial that has x squared plus something x. Okay, there cannot be an x squared, a plain old x term in this for it to work. All right, that's it for today. We'll see you tomorrow.